Hi, and welcome to our handheld laser scanning for design and construction webinar. My name is Julie Schmidt, and I will be the moderator for today. I am the support manager at point3D. There's just some housekeeping notes. All attendees are muted, and if you have any questions, please enter them into the question box on the right, and we will be answering all the questions at the end of the webinar. Our presenters today are Greg Laws from point3D and Chris Ahern from DotProduct. Greg, we'll let you start.
Good morning. Thank you. I am, as Julie said, Greg Laws. I am principal at point3D, and at point3D we are both LFM and DotProduct partners. I will be speaking and sharing the LFM information while Chris shares information about DotProduct. So LFM 4.4 is a big release that has just come out the past couple weeks. On the DotProduct side, it has been a big deal for us. Improvements to LFM, DotProduct, direct file, import of the DP file format. For those that may have used this in the past and have worked with PTS and PTX files, the DP file is much smaller, much easier to work with, supports color, supports DotProduct's coordinate systems. The LFM project and its handling of the DP data is much improved. We have a single scan with which to work with, and very happy about, and I hope you'll be happy to see the new improvements. As I said, LFM 4.4 is a big release. In addition to DotProduct, there's a number of other features, net view, bubble view volumes, 3D tagging, and HyperBubble that are in this version, and we'll be talking more about them in an upcoming webinar. On to you, Chris.
Thanks, Greg. So, as Julie mentioned, Chris Ahern here from DotProduct, our marketing manager and resident handheld scanning expert, to show you the DPI-8 kit live in action today. So first I'd like to introduce the kit itself. So here you see an image of the DotProduct DPI-8 scanner, and this is what I'm going to be holding and actually broadcasting the screen live from momentarily. This slide outlines it actually as a component of 3 parts. So the infrared sensor itself on the back, the NVIDIA Shield tablet, which is what's powering everything. It's a standard Android tablet. And the core of what we do, which is the point3D software, which allows for the real-time, accurate color 3D capture that you're going to see today. Next slide. So just briefly, we are, as of last week, have released a brand new beta program for some new software that I'm actually going to be giving a preview of today. First off, on the left here, you'll be seeing some features from Dot3D, which is our new viewing and editing application that operates side by side and is included on the device. And we'll also have a release on Windows as well. It includes 3D touch cropping, annotation, more advanced precise measurement, and more. And there's a lot more to come in that application. We're also releasing a brand new version of point3D 2.1, which includes some improvements in tracking, optimization, accuracy at depth, as well as many new integrations, including direct wireless registration with ZNF laser scanners, and the integration directly with Dot3D, which you'll see today. Next slide. So briefly, here's a growing list of today's applications for our technology. So it goes from anybody who's experienced with tripod laser scanning and wants to fill in more detail on some of the hard-to-reach areas or particular areas of interest, to a wide variety of applications of users who are already using 3D or even those who are brand new to 3D. So everything from, as we see on the list here, BIM and as-built documentation, so engineering and construction, oil and gas asset management is big for us, and the piping industry in general, which is also some of the early adopters of 3D laser scanning as a whole. On the right here, you'll see the largest image highlights a project that you can download on our website as a case study from Step Change Engineering, and this is a perfect example of where our technology comes into play. It was a modification to an offshore oil rig in a particularly complex area. Obviously very limited time on site and needed to get some accurate data of what was actually there before they drew in the new design model, as you see in the bright colors here. So it plays very well with filling in gaps, but also as a standalone tool for those standalone modification and renovation projects. Moving down the list here, the applications do spread to architecture, real estate, custom design and installation, so again, that renovation realm, crime scene forensics and accident mapping, archaeological documentation and digital heritage preservation, just to name a few, but you'll get a grasp on what it can do and where it can be applied once I show it live in a second. Pass it back to Greg.
Thank you, Chris. And can everyone see that? We're going to take a quick look at the workflow that we'd like to demonstrate live. And as with any project, the first part of the project begins with a little bit of pre-planning. We are going to be talking about scanning with the DotProduct and then integrating with CAD data, with existing scan data, with other information. So the first question that has to be answered is, how am I going to position my DotProduct scan data? And I can either align it to a CAD model by picking a coordinate point from the CAD model. I can align it to existing scan capture information. I can align it to survey control, or we can use local coordinate systems and align arbitrarily. On the right, the images show two of the target types that are used within the capture: the black and white target for survey and survey alignment, and the April tag that Chris will talk a little bit more about in the live demo. So to position it, two pieces of information I need. Where is it going to be? Its location in XYZ coordinates, and then its orientation. So if I'm extracting this information from an existing scan data, I'm going to query a point and get its coordinate information, and then I need to identify the direction, the orientation that I want the scan data to be facing. Typically it is a YX or YZ, the first axis taking precedent in orientation. So we're going to take a look at using existing scan data for alignment. We are looking at LFM, and we're looking at a volume from a 3D view. In an LFM, I can pick any point in the model, and it will provide the information in the lower left, the position. So I would then want to make sure that when I'm scanning that I'm capturing that same quarter so that I can align corner to corner. The information that's shown in the lower left here is in meters. You just want to make sure that you are setting that and recording that information in the unit system, be it inches, feet, or meters that you're going to be working in. In LFM, I can also extract that same information from a bubble view. And here we see that we've picked the same corner of the building, and this time I'm getting the same coordinate information. So we know where we want to orient our scan model. It's time to begin. This is the DPI-8 that Chris showed a few minutes ago, and we are live scanning in this picture from the Eaton Center, the Eaton Technology Center in Houston. Chris will talk more about what we see on the screen, but the yellow and green is giving feedback that he is collecting and getting good data. One of the first things we want to do is save that information before we proceed and do anything else with it. File menu, click File, Save Scene, and then Proceed. The next step is optimization. Chris, once again, will talk a little bit more about this, but this improves the spatial alignment and color balance. There are different options depending on whether I'm using targeting or not. April tags improves the spatial alignment. My data is optimized, and now I need to set position and orientation. In this image here, the arrows are pointing to two options. I can set an origin point, that'll be the 0, 0 point, or I can assign a coordinate to that same point. Once I pick the point, I have a menu that comes up and allows me to key in the coordinates that I queried from my CAD model or from my scan data. Be sure to set your units here to match the units that were in your query extraction. Having set the coordinates, the next step is to set the alignment, the orientation, and in this scene we see a blue circle and a green circle. To set the alignment, we pick the first axis of precedent, and in this case it was the blue circle for the floor that set the z-axis, and then the second point that we picked was on a vertical surface of that concrete pedestal. Now I understand that we had a very small surface to pick from. Ideally, if we're picking points on surfaces, we want to be picking larger surfaces to minimize error, but in this case we worked with what we had. Data is collected, data is saved. I'm ready to move on to the next step. Chris talked about the new .3D application. Here we're looking at scan data collected, and we're looking at the application on a Windows system, a Windows laptop. Great addition to the portfolio of tools so that now I can get a better look at the data, take measurements, do cropping before I proceed. On to LFM. The first step is to prepare the project. We can bring this information into an existing project and regenerate, or in the cases we're going to be showing, we're creating a new LFM project. We're looking at the view from LFM 4.4, and for those users of prior versions, the menus have changed a little bit, but it's still that same look and feel that you're used to. LFM import, I have named my project. I have created a register group, and then within that register group, I've selected import. In the past, we would have selected PTS to get one consolidated scan file. We're now bringing in the .dp file format. It's a much smaller file, a lot easier to work with. Color comes in great. We pick the file, select, import. The next major step is generating the database to work with. In this case, we're looking at the DP file alongside a ZNF scan. We're going to set our generation settings, process, and in a couple minutes, I will have an LFM data set. We're going to take a look at this whole process live in a few minutes when Chris gets done collecting. Back to you, Chris.
Thanks, Greg. So now everybody should be seeing my tablet screen live. I'm going to forewarn you, the price of a truly live screen share and a truly live scan, there may be a little bit of lag, it may be a bit choppy. So I will move through my scene perhaps a little bit slower than I normally would to try and keep in sync with all of you as best as possible. But you should at least see my screen now. So this is my point3D application running on my DPI-8. A quick sample of what we're going to be scanning here. If I pan around the room, you'll see some piping systems that have been set up in our mock industrial scenario here in the corner of the room. These tags you see here are what Greg mentioned earlier, are called April tags. And what they do is they're not for geolocalizing the data as you could with standard checkerboard targets, but they're going to automatically improve the accuracy of your data on every scan you do without any measurement or other manual input whatsoever. And all it requires is that you go over each individual tag at least twice to get the value out of it. Because what it does is it recognizes I've been to the exact center point of each of these individual tags more than once, and I can align my data even more accurately than I normally would based on those exact target center points. So in essence, the most important part is I'm going to start at these two tags you should see on my screen, and by the end of my scan, I plan to return back to those two tags to lock it in very tightly. So next, I'm going to hit Start Mapping, and we'll be capturing data live. You'll see that target turn orange, so I know it's been recognized. And as Greg mentioned, the green and yellow is real-time feedback on the quality of the points that I'm collecting. So this is based on angle, distance, reflectivity, and other factors. But you know not only what you've captured, but exactly how well you've captured it. So whatever it is you care about, you want to make sure you paint nice and green or at least yellow. You can see the shadows in real time, for example, behind this pipe, and I walk around and fill it in. So you're fully mobile to move throughout the scene, and it really does feel like spray painting. You'll see I've scattered April tags throughout the scene. Again, those two that I start at and return at are the most important, but you can do many loop closures throughout the scan. So anytime you go over any of these tags more than once, it's going to help your scan. And when you are dealing with, large areas of flat or white walls, they can also assist with your tracking. So I lost tracking there. I just got to back up, and it'll find itself very easily based on the geometry in the scene. So now I've gotten a pretty good sample data set of the two pipe systems here in the room and the walls behind them, so I can hit Finish Mapping. And right now it's quickly processing the data, and we'll be able to view it right away on the tablet. So immediately I have my unoptimized scan viewable right here on the tablet. You should see everything we just scanned in full color. But I mentioned it is unoptimized. So there's an onboard step to process the data. This is when these targets are implemented. It's when any other hard targets or scale bars are implemented. So I'm going to go ahead and start that process. Use April tags. So what the optimization is doing is even without targets, it's tightening the alignment of the data. It's leveling and improving the colors. It's cleaning any obvious noise that it recognizes and improving the overall quality. If you were referencing the data using hard targeting, for example, if you had 3 checkerboard targets with known coordinates, this is when those would be taken into account to both improve the accuracy, similar to how April tags do, but also rotate and translate the data into another point cloud or a CAD model, for example. Another workflow that can be used to improve the accuracy is scale bar targeting, where you set a single or multiple known distances in the scene, whether you have a physical bar or you're taking measurements on the fly. You can reference it that way too. And this is all just to give you an added confidence level. The data is going to be very accurate on its own, especially with the use of April tags. So it should be done here in just about another 5 seconds or so. And if you see any sort of slight blurriness in the scan, you should see it crisp up nicely and all the colors brighten up as soon as this finishes processing.
Chris, an obvious question users are going to have is the accuracy of the data. Can you comment on this?
Sure. So in a general scan with this device is approximately a 20 by 20 foot area. And using the right targeting methods, you're going to maintain the accuracy of approximately a 1/4 inch across that spectrum. So it's a very reliably accurate device, but is by no means sub-millimeter or reverse engineering grade. So next, so first off, let's take a look at the data, make sure I got everything I need. So here's my scan. It looks very nice. This is my photo rendered view. I can also switch to the point cloud view, where you can actually see every single XYZ color coordinate that was captured, and zoom in and out, rotate and translate with the touch of your finger. My next step is going to be to go to the Coordinates tab here next to Optimize. This is what Greg mentioned earlier, where I'm going to reference my data. This is valuable whether I'm referencing it, to another cloud or model, or if I'm just trying to position the data properly within itself and make sure it comes in upright in my post-processing software. So I'm going to zoom in on the corner here and tap Set Origin. Now I can tap any point in the scene to set my XYZ axis, so I'm going to tap the corner point here, and then I want to set my Z axis straight up. So I tap the Z primary button and tap the floor, and now I want to do the same for my X. So I tap the X secondary button, tap the wall. So now my XYZ system has been set. Everything in my scene is referenced based off that. So even here within point3D, if I want to get a quick clearance on this sample, I can do New Measurement, and then tap the floor, and then tap under the pipe. So I can do that again and tap it a little bit more accurately to get truly underneath it. But what I got here is not only my point-to-point 3D distance, but I also got my X, Y, and Z, so 3.33 feet from floor to pipe, or at least to where I tapped it. So that covers a lot of what you can do within point3D. So next I will go to my File tab where I can save my scene. It's powerful to work in that DP format, as Greg mentioned, because that's about 30 to 40 times smaller than your standard point cloud formats, which you may have had to export to in the past, PTS, PTX, POY, or PTG. So now we're just going to stay, however, in that DP format, name our file, and save the scene. I will save it as LFM Webinar 1, and I tend to put an OC at the end to tell myself I've optimized and set the coordinates in the data. I'm going to use my user-defined coordinate system as opposed to any other options here, since I did just set that, and hit Save Scene.
Chris, if I have forgotten to save, have I lost the data after I've done a capture, or is there an autosave function?
So the good question. There is an autosave function. A lot of people who are used to point clouds and 3D scanning find this hard to believe, but every single scan you ever take is automatically saved in the unoptimized format directly to the hard drive on your tablet. Because these files are so small, it's never really an issue, and if it ever got to it, you could clear it out very easily. But there is an autosave folder directly on the tablet, so you never have to worry about that. So now that I've saved it, I'm going to do Send Scene 2. And this is where we're going to show the integration with the new sister application on the tablet called DotProduct. But you'll also see here in point3D 2.1 we have a few different integration options that are new. We can send wirelessly to our ZNF laser scanner using the Laser Control Scout application on the Surface Pro tablet. Coming soon, we will have a partnership with Elysium to do some feature extraction and export also here on the tablet. Of course, we're going to be soon tapping Open Scene with DotProduct, although you also now directly in point3D have the ability to share via email, Google Drive, Dropbox, etc., which is how I'm going to be sending the data to Greg. But I'm going to do that from DotProduct where we have the same function. So I hit Open Scene with DotProduct, and this is opening up my new application. So now we see a nice full screen rendering of the data. We have that same functionality to switch between surface-based rendering or point cloud view, whichever you prefer. Each application varies as to what looks best and what fits your use case. So I'll again move left to right down the tabs here to show you some of the new features that we have in DotProduct. First is the more advanced measurement functionality. to a certain degree. There's more measurement features to be built in here, but for now what we have is a more accurate measurement capability with draggable endpoints. So I can hold to tap on this pipe, for example, and I start my measurement. However, obviously I'm just tapping with my finger, so how exact can that be? I now have the ability to drag that endpoint, say to the exact connecting point of this pipe here, and this is in the photo rendered view. It will see how well it shows over the broadcast, but it's even better to see it in the point cloud view, where I'm actually dragging a red dot around my scene from one point to the next, and you can see exactly which point I'm dragging it to. So that's the measurement capability. I'll show it here as well, where you are actually dragging basically as exact as you can get with a point cloud measurement. So next I'm going to move to the Edit tab and start cropping. And this is probably the most powerful feature that we've added. And it's the ability to do very quick, easy, and user-friendly touch cropping of the data before you even take it off the tablet. And this is powerful not only if you're doing a single standalone scan and you want to clean it up a bit, but also if you're going to be registering the data or aligning it to other point cloud data. If you have some, stray points scattered throughout the area that you didn't actually care about, you don't want those to be used, overlapped, or taken into account during the registration. So in this scenario, we're going to say that what I care about is this corner of the room and these two pipe systems. So I can move both my box and my scan. The box is moved by tapping these green circles, and the scan is moved with a two-finger drag, and select the area that I care about. So I'll hit Select on the bottom left. Now I've captured this full area in 3D, and let's say that I actually wanted to include this metal panel here. It's a multi-crop capability, so I can zoom in, adjust, and hit Select again. Now I've added that area to my cropped scan, and next all I have to do is hit Invert and then Crop. So that's a very quick and easy way to clean up your data before you take it off the tablet. Lastly, I wanted to show a quick example of the new annotation capability that we have in .3D. And what this is a simple way to take as many 3D annotations as you'd like and save them directly to the DP file. To date, this will only be shown in other .3D applications running on other computers or tablets, but we hope to build these notes into our integration with other software like LFM Server in the future. So if I hit Add, and then I can hold on any point in the scan. For example, my pipe here, I can name it Pipe 1, put in any detailed notes I'd like, and then save the annotation. And you see that that is a full 3D annotation as I move around the scan, and it can be toggled on and off. You can make as many annotations as you like and add as much in the notes as you like, part numbers, specifications, etc. So the idea behind .3D is to make the sharing of the data easier as well. So if somebody else is running this application, you want to take some crops, notes, and send it to them, they can open up that DP file directly using that sharing functionality. But also if you just want to take some screenshots and send it to somebody via email for a very easy way to view even multiple angles of a measurement you're trying to show or a decision that needs to be made. You can position however you'd like and snap some quick screenshots using the screenshot button that will give you some screenshots of just the data itself, not any of the menu bars. So let's say I just wanted to get that angle and this angle, and it's really that easy. So next you go to the Share button, and it gives you the option to share your last screenshot, all screenshots, or the DP file, which is of course what we want to be sharing now as I send that over to Greg for use in LFM. So I'm going to use, actually one thing you always want to do first is save your file, so I'm going to hit Save.
So Chris, this looks like a great application for construction sites to communicate problems, changes, issues back to the home office. It looks to be very easy to collect information, annotate it, send it back, and let engineering design take a look and perhaps take their own validating measurements.
Absolutely, and it's really powerful for that classic scenario where you're in the field trying to install a system and it doesn't fit the way it's supposed to. You tell the design team back in the office and they say, yeah, it does, make it work. And you want to capture, show them exactly what's there. They can send you the new specs based on the as-built in the field. So it's designed to be the quickest, easiest, and most user-friendly way to do that. So that file is now already on its way, and the upload has completed. So that has sent to Dropbox, and Greg is going to be able to bring it down directly and show you the easy import of our DP file into LFM Server 4.4. So with that, I'll go ahead and pass it back.
All right, you should be seeing my cluttered screen 1. And while we're waiting for Dropbox to do that transfer, then I'm going to do an update again, see if it's arrived. So we'll give it a minute or two longer. While we're doing that, I'm going to jump over to LFM. And we talked about the Eaton project, and I had some screen captures in the summary. We're looking now at LFM Server. We're looking at LFM Server 4.4, and we are in ortho mode. And what I've done is I've used the volume select to isolate a couple areas. I'm going to switch over to perspective. And so we're looking at both Z and F imported into LFM data. This was data captured with a ZNF 5010C, and we're also looking at the same area captured with the DotProduct. And I point out this feature here is a good point to show accuracy, alignment, and how well registration worked. In this case, the data sets were aligned using survey control. We're looking at this particular panel box, and when we came through with the ZNF scanner, the door was closed. When it was captured with the DotProduct, the door was open. So we can show two different cases. It also shows how well the data is aligned together. If we switch back to the ortho view, reset, and I can see the extent of my ZNF scan within the scene, and then the DotProduct information overlaid accurately in the same location. You're going to see some color differences between the two sets. The ZNF scanner is capturing with a HDR camera. The DotProduct is capturing color, but it's not HDR. So we will see some subtle differences in color, and it helps you tell which data came from which. Let's see how we're doing on that. Import. All right, there we go. So let's go ahead and download the file, save to my Dropbox. Back to LFM. We're going to close this data set, but before I close it, I'm going to switch over to gateway mode because that's the mode that I want to be working in. Close. And then I'm going to open up, and I prepped a blank data set. So I went through the steps of saving a new project. I previously created a new register group. Register groups are organizational groups. If I'm doing a building, I might have different register organizational groups for each floor or different unit areas. And the register group then is what defines what is created in the LFM database. So I'm going to import into this group. And let's browse over to my Dropbox. And let's determine where we want to save this. So in our structure, under Server, I have a Scans folder. Select it. And it's going to import. So at this point, it's building the LFM scan file and any necessary resource information. If I'm doing multiple files, I can pick 1, 2, 20 files, and it'll begin processing. I control how many files that it'll work on at once by this setting here under my options, gateway options, and I can control the maximum number of simultaneous imports. This number, the maximum number, is your number of cores less 1. If I'm doing batch importing and I don't want to use the system for anything else, I'll drive that number up to the maximum, which in this case I have 8 cores, would be 7. If I'm also trying to get work done at the same time, I'll bring that number down to 1, 2, 3, or 4. And if I'm doing registration after the first one is complete, I can always start working on it while it continues to import. Before I proceed, I'm going to save. I'm going to double click to center it. I'm going to click Load Points. And what we have is the data. Now, Chris, I think you were a little aggressive in your crop. So we've actually taken out the front set of piping. This would be a quick call to the field, hey guys, recrop that, resend it. Within minutes I'd have an updated file. But we're going to work with what we have here. The yellow tint is yellow because that's the file that's selected. When I deselect, you can see our natural colors again. We're going to go ahead and take the next step and just show you how easy it is to create a LFM data set or database. First thing I need to do is right-click on the register group that has the data I want to build my data set for and bring up the Generation Settings tab. And it's giving me a warning and saying that I really need to save this first, so we're going to save, close, exit, and then reopen LFM. The data set generation and import tasks are somewhat memory intensive, and we always want to start with a clean slate. With the webinar running, I've lost my background screen, so I'm going and doing it the hard way and dialing in and finding LFM 44012. Open Recent. Select the register group, right-click. Once again, we're going to set our generation settings. The first one is, where do I want to build that data set? By default, it defaults to my project. Intermediate points is where our temporary files are created for its processing. On a small data set, it's not critical, but if you're doing a larger project, you want this typically to be on a separate drive from your normal data processing drive. So we're going to go to C drive. We're going to go to a folder we keep for this. The folder has to be empty. I did generation earlier. I need to delete that folder, contents. And I can do that because I know the only thing that should be in here is temporary LFM files. Select the folder. Final points location is based on my initial selection here. And my points files go into a subdirectory called points. I do have the ability to generate a database on everything, or I could set a volume and I could create a smaller data set that's just of perhaps a particular piece of equipment or a particular unit area. We have a density setting. Most of the time you're doing full. The only time we do less than that is if we're creating a quick test data set to check our registration, I might check the quarter density. And then color, I do have, by default, if it's color data, it will be checked. I can create it with grayscale. Go over to the Generation tab now that all my options are set. Click Dataset Generation. Yes, I want to proceed. And this should just take a couple moments. So while this is getting ready to start, a couple notes for you service provider folks in the audience who are used to generating data sets for your customer. This should be part of your standard. You should be used to this workflow. You should also have your LFM server and dataset generation license. For the end users who may not have done this step before, may not have a generation license, as long as you have an valid LFM server license, you have a Generation Lite license available to you so that you can generate data sets up to, I believe it's 25 scans, so it would certainly allow you to create data sets of these DotProduct scans for use with your existing project information. So that quickly had finished, and of course it should because it was a tiny scan. Double click centers my view. I'm in that perspective view. We can switch over to our ortho. Typically, one of the first things that we're doing is we're selecting a volume, so I'm going to isolate this point set. In my plan view, I define the X and Y bounding box. I will define the elevation. And my volume selection box comes up and says, based on the points you picked, we're going to select a subdraw value of 3. Well, I know what graphic card I have on the system. I'm going to push that a little bit higher. I'm going to hide the rest of my low-res data. I'm going to say, okay, it's going to generate a box, and now I can look at just that pipe set. I can switch over to perspective, and there's perhaps that pipe that was in question that was clashing with that new piece of equipment, and construction is looking for an answer quickly on this. So I'm going to click my measurement tools. I've clicked the diameter measurement. And I've got my text size set pretty small, and I have it set to decimal feet, but I get immediate feedback on diameter. And if I'm running a CAD-Link application, I'd be able also to set tie points perhaps on this cylinder. The other measurement functions, I can take a single point and get an XYZ coordinate, or I can pick distances. So from field to engineering desktop, in a matter of minutes, we're able to capture information, transmit it, and send it back to the home office, to design and engineering for their review and their query. So with that, Julie, we're going to move on. I see that we're heading toward the end of our hour. I'm going to head back to you and our recap.
Okay. Let's see. There we go. All right. So go ahead. You go. Basically, we've shown rapid capture with the DPI-8 and integration with the LFM server. We've got the DotProduct handheld laser scanner showing the quick capture and view with .3D, the coordinate system, and the on-tablet measurement. The LFM Server 4.4 software, the powerful point cloud engine with its unrivaled visualization, handles 1 to 10,000 without blinking scans, hardware and CAD application interoperability. Chris, if you want to go over a few of these new DP features that we went over.
Absolutely. So just to highlight again, we flagged some of these new features that were shown today. So on the .3D side, we saw a screenshot of Greg using the Windows-based version, and we saw myself live using it on Android. So this is a coming soon program in beta for all of our customers on current support and maintenance contracts. We were granting access to the beta program, and it's operating on both platforms. We saw the 3D cropping, 3D annotation, the precise point-to-point measurement capabilities, and the enhanced sharing, and that's both in .3D and 5.3D. You've got much easier ability to send the data or screenshots straight from the tablet. We optimized the data in 5.3D, demonstrated the direct integration with .3D, and again, that sharing functionality, as well as a quick view of some of the buttons we now have for some improved integrations that you see listed here.
Okay. And then, Greg, if you want to go over the LFM features.
I will. We're going to switch things up. We're going to go live on this one, Julie. I talked in the very beginning about LFM 4.4 being packed with new features. I talked about some of the new features in LFM. The important one that we were talking about today being the DotProduct, but also a lot of visualization. And so some of the visualization features, and let's see if you can see my screen yet.
Yes, we can.
What we're looking at is HyperBubble, and HyperBubble is a new visualization technology that is in LFM 4.4. We're looking at a user in real time just driving through the scan data. We happen to be in New York City. We happen to be on a rail project, and we are literally driving through the points. The user is just moving his mouse. And I'm going to pause this for a second. I'm going to stop this one, and I'll load up another one. So new visualization, it's real time. It's taking scan data, and very shortly we're going to have the ability to bring our DotProduct scans into this same mode and look at DotProduct scans just as we are looking at this terrestrial scan data. Back to you, Julie.
Okay, now we'll take questions that have come in. Chris, the first one is for you. Is there anything to indicate you collected the targets twice, the April tags that you were doing?
Yes, absolutely. So when you pan back over the target, you just need to watch it turn orange again. So the same indication you got the first time. However, when you pan back to it, you'll notice that it takes a second for it to turn orange again. So that's how you know.
Okay. And is there a crosshair option other than the blue dot for selecting points?
Yes, there actually is, and that is another feature in .3D that I didn't show today. However, in both the annotation mode and the measurement mode, you now have the option of either selecting with a finger press or selecting with a crosshair, where you can translate and move your scan around with a crosshair in the center of the screen until you're in the exact point you want to select, and then you just tap, and it selects based off the crosshair, which is an even more accurate and precise way of selecting those points.
And so that's only in the .3D, not in the actually on the tablet when you're in the 5.3D. Is that correct?
Right. It is on tablet or in Android or on Windows, but it's in the .3D, the new sister application that we've released in beta.
Okay. Is there a way to lock the XYZ axis when dragging for measurements?
Yes. The XYZ axis is locked in place. Even if you're moving the scan all around upside down, it's still referenced to the same XYZ system. So I'm not sure if that answers the question, or maybe I don't fully understand it, but it is locked in place.
This is Greg. So once you've set the coordinate system, it is set until you change it. And then when you're picking the points, if you remember the feedback that Chris showed, you're getting a point-to-point distance, but you're also getting the X, Y, and Z component of those distances.
Okay, another question was, can you export the data set to a file format that can be incorporated with other scanner software such as Leica Cyclone?
Yes, definitely. As I showed today, you can export to those industry standard formats for maximum compatibility, so that's PTS, PTX, POI, or PTG. However, our DP file format will actually also go directly into Leica Cyclone, same as we did today, and that goes into about 20 programs so far.
Okay. And it's not possible to have the bubble views or HyperBubbles with DP files right now, but it is planned in the future. Is that correct?
That is correct. So today and now we're working with DP data in the 3D view, and it almost looks like a bubble view. The typical DP data that we see collected is very dense, but yes, that is correct. The bubble view only works with structured spherical data. One of the big advancements with the HyperBubble technology is the ability to work with both spherical and unstructured data, such as the DotProduct and mobile LiDAR. So this is something that is coming very soon.
Question that says, this is for you, Chris or Greg, is anyone using DotProduct to create mesh models that can be exported in the .obj format?
I can answer that, and the answer is yes. There's no single workflow for doing that, but our data in the point cloud formats that we export will essentially go into any program that works with point clouds. Even if you have to use some of those larger files, we do export them directly. And we're seeing meshing done with the free programs like MeshLab for the smaller scale scans, or paid programs like 3D Reshaper or 3D Reconstructor. And then on the high end of the spectrum, there are some more powerful meshing tools as well. But it is a standard point cloud, so it's absolutely a workflow that we're seeing today.
For users that may not be aware, there's another great free tool out there. It's called Cloud Compare. And Cloud Compare is a point cloud visualization analysis tool, and it too has the ability to create meshes from the point cloud data.
Absolutely, and our DP file format will go into and out of Cloud Compare.
While we're waiting for another question, Chris, you spoke briefly about accuracy, but let's just talk about that for a second, because this is something that always comes up. Expectation of accuracies compared to tripod-based scanners, compared to other solutions. Where does this fit?
Sure. So the expectation of accuracy is comparable to your tripod-based scanners, but on a closer range, on a smaller area. So it is expected to be within that 3 to 5 millimeter range when scanning in a close quarters scenario. If you want to scan larger areas, add confidence to your data, or just ensure the highest accuracy possible, that's how we built in these scale bar and hard targeting workflows. So with hard targeting, what you need is 3 or more checkerboard targets with known XYZ coordinates. So it uses those as exact hard points to both tighten alignment and accuracy of the data, also used for georeferencing the data. With the scale bar workflows, you're actually just simply specifying the exact distance from any point to point in your scene. So you can come in and take those measurements, say a point to point on the floor or the wall, to get your X, Y, and Z axis, and then reference it that way, and then process those targets on the tablet. Or we've actually just announced last week, in collaboration with a measurement company by the name of Brunson, a new scale bar kit that allows for fully automatic scale bar targeting. So it's a 6-meter kit where you can set it up in any combination from 6 meters is a single bar, or 3 2-meter bars, or anything in between. And the software is actually smart enough to recognize it uses the same type of April tags that we saw today, but a very specific set. And it recognizes, oh, that looks like it's about 3-meter Brunson scale bar. I know it's exactly 3,200 millimeters, and I'm going to reference everything behind the scenes based off of that. So it's a new add-on package that's available in a really powerful workflow to get the highest possible accuracy without any manual input or work whatsoever other than laying out some bars.
So someone in a nuclear application might be interested when they are collecting data during an outage in a dry well, for instance, and perhaps they might not be able to get into that space for another 6 to 24 months, and they want to guarantee the accuracy of what they've collected?
Absolutely. So, and that would be a great scenario for this scale bar kit as well, because, they might not want to have to go through the effort of taping up some targets and taking some measurements. This takes all of that out of the equation. You can just lay out the bars and whatever distances are most important to you, and it's not referencing, of course, not just referencing that exact distance, but every other point is referenced slightly more accurately based on the known point-to-point distances that you put in there.
Are there any limitations that the user should be aware of the technology? And
absolutely. So I think I mentioned earlier, but in case not, the range of the device is 2 to 12 feet. So you can't walk into a giant auditorium and just point it around. That's still going to be a job for a tripod laser scanner, and that's why this works really well to fill in more detail on those hard-to-reach close quarters areas. In addition, it's primarily an indoor tool. We definitely have customers using it outdoors. However, it does not work in direct sunlight. So you can be scanning early morning, as a lot of our construction customers do, in the evening, on a cloudy day, or in the shade, but you can't rely on it to be scanning on a sunny day at the 50-yard line. It's just a limitation of the sensor. So primarily indoor use or outdoor use under the right conditions.
Does this work with any tablet? What is the tablet that is being specified, and is there auxiliary storage for the tablet? So let's say you're doing a large project and you want to organize your data perhaps into different areas.
Yes, so the tablet itself is an NVIDIA Shield tablet. The complete kit is delivered with everything you need to start scanning. So from the software to all of the hardware, the tablet and the sensor itself is all included in a ruggedized carrying case. And the reason we use that NVIDIA Shield tablet is it's a powerful tablet actually designed for gaming. So it has a powerful processing chip and a large memory size, and works really well with what we do. It does have upgradable storage. If you want to drag files over, you can input an SD card, no problem. But it comes with 16 gigabytes natively, and that will always cover you for the amount of time you'd be scanning with. The option for battery life, which could be considered another limitation, continuous scanning, the battery will last for about 2 to 3 hours. However, we offer the ability for our customers to pick up a second tablet, and that will allow you to hot swap in the field, charge one while the other one is scanning, and scan for an entire day that way. And it's a very affordable tab of $300, and that's an easy way to add battery life to your device.
Chris, another question was, can you do crosshairs when picking the point for measurements?
Yes, you can. That's a new feature within DotProduct that you are able to do that, where basically the default is to press and hold to select a point, but if you want to be more precise with it, you can select in the bottom right corner, there's a crosshair option, and you'll be able to have a crosshair show up in the center of the screen and essentially point and shoot to where you want your annotation or your measurement to be. So that's part of the same thing we're doing with the draggable endpoints to give you the most precise point picking possible. Another aspect of the technology worth mentioning, we mentioned the scale bar kit, we've mentioned the ability to add a second tablet for extended battery life. The only other two options that are out there as far as accessories go are a light kit, so you can actually, it's again an affordable option, $215 if you're going to be scanning dark scenarios at all. the device itself will perform well anywhere that's lit well enough for a decent photograph. That's a good comparison. However, if you're in pitch black, you can actually mount this kit on very easily, and it's a light that has a diffuser on it, so it's wider in field of view than the camera itself. So you can capture good full color data and shadowless data even in complete darkness. The second option that you have at a similar price point is a full kit to mount to a standard survey pole, and that allows the user to mount the scanner to a pole that extends from 6 to 12 feet away from the hands of the user, while maintaining control of the tablet at the base. So you put the sensor up top, and it actually has a powered USB cable that allows you to control the tablet at the bottom. So you can still see everything you're doing, even when you're reaching up high, say above rafters, or down low, below ground, for example.
Okay, that's all the questions that we have for now. Okay, that's all the questions we have so far. Anybody else have any? You can send them in. Otherwise, you'll be getting an email with a copy of the video and information, email addresses that you can contact us if you're if you have questions, or if you're interested in purchasing the DotProduct unit or the LFM. We have our...
And Chris, if I could interrupt for a second. Chris, you were showing today beta versions of the .3D and the Phi3D software. Are these available to users today and now? How would they get them?
Sure. So they're available today to all current DotProduct DPI-8 customers who are subscribed to active support and maintenance contracts, which keeps you subscribed to such upgrades in the future. And the first 12 months are included, so anybody who's purchased in the last 12 months, it is available to them. And for any who have purchased before that time, you need to renew with your DotProduct reseller or DotProduct directly.
Okay. There is another question. If the DP data is being added to an existing data set using a frame at a picked origin, and error is seen after import into LFM, can the DP file then be moved to better align with LFM?
So the answer is yes, and you have a couple tools at your disposal. In gateway mode, I can select the scan, I can right-click, and I can do a manipulate. And manipulate allows me to move in the 3 axes, and it also allows me to rotate. And so this is another technique that we use to align. I will align it, and then I can use the LFM cloud-to-cloud alignment. And typically the way that we do this, we'll create a sub-register group. We'll move the scan that we want to use as the reference scan into that group. And then we will manipulate, align the DotProduct scan to get close, and then run cloud-to-cloud registration on that group, and it'll tighten it up. If the scan, the DotProduct scan, is way off in space, the first step that we'll do is pick a point in the LFM scan that's close to where we want the DotProduct to be. We will update the header of the DotProduct scan in LFM. It'll position it approximately where we want it. We'll do the manipulate, the cloud-to-cloud alignment, and typically that's all it takes. If anyone is interested in seeing this, we can set up a web share between you and us, and we can walk you through that procedure.
Okay, another question was, can the complete point clouds be exported to Autodesk Recap?
Good question, yes. So and I guess it can from either place from DotProduct. Chris, you want to talk about that, and then I'll talk about LFM?
Sure. Similar to the earlier question, Recap is another one of the programs that will read our DP file format directly with a free plugin that we offer. So you can bring it in directly that way, or of course through LFM, as Greg was about to mention.
So in LFM, in server mode, I set a volume of the area that I want to export, and then it's a matter of just selecting the export function, and it'll create a recap file of that data.
Okay, and then is it possible to manage laser scan revisions in LFM?
There is no automatic, but we would suggest managing revisions through the use of register groups and file naming protocols so that my register groups might be named for the unit area and the date. The LFM project supports multiple data sets, so I can have an LFM project that's comprised of different LFM data set or databases, and then I can turn on or off the data set that I want to look at. So if I had the same area captured multiple times, I could then turn on or off the data from the specific day I wanted to look at.
Okay, that's all the questions that we have right now. Thank you for attending the webinar. We will be having another one at 2 o'clock in case anyone you know would like to see it. Please let them know. And we will be sending out a recording of this webinar. Have a great day.
Thank you.